Okay, let's start with a problem that we have looked at previously, and what we're trying to do is we're trying to find all solutions for theta between 0 and 2 pi. And we're solving the equation sine of theta equals negative 0.3. Alright, and so I graphed this interval 0 to 2 pi, right, 6.28-ish, here so that you can see what this looks like, and then the red line is the negative 0.3. So you'll see here that there are two solutions, right? One here and one here. Okay, so let's solve this. And if you do inverse sine, right, so you do theta equals inverse sine of negative 0.3 radians, right? And your calculator tells you that that's negative 0.305 radians. But that's not between 0 and 2 pi, right? Remember that sine is negative in quadrant 1 and quadrant 4. This is negative 0.305. So what we need to do is we need to find the positive coterminal angle. So we do negative 0.305. My decimals aren't sticking, but plus 2 pi. And that gives me 5.978. And then I do pi minus a negative 0.305, right, for this one over here, or plus, and that gets me to 3.447. So this is the 3.447, and this over here is the 5.978, and those are my two solutions. So theta is equal to 3.447 or 5.978. Alright, so hang on to these two numbers. We're going to revisit variations of this equation in the next couple of examples. Okay, let's take a look at our second example here. Now notice that this is slightly different, right? We're trying to find all solutions between 0 and 2 pi. Notice that I changed the period of my function, right? The b here is 2. And so it's important to find the period first, just so that you know how many cycles of the function you'll see between 0 and 2 pi. And remember that's b, and that period is equal to 2 pi over b. And so here b is 2. So the period is pi, right? So it's going twice as fast because I have half the, my period is half what it typically is. So I have 2 cycles of my sine wave here. And so if you notice where this equation is equal to negative 0.3, I have 1, 2, 3, 4 solutions between 0 and 2 pi. Alright, and so that's what I'm going to need to find. And so here's where we're going to start. You always find the period first because you're going to need to basically find the corresponding angle in the next period, right? So here's what I mean by that. So if you solve for this x value here in your first cycle, right, if we know that the period is pi, then we'll see another recurrence of that same value, right, of that same intersection. Likewise here, right, I find my second solution here, but I know that between 0 and 2 pi I'm going to have another one, and that's this one here. So basically I add pi. This distance between the two solutions is pi. So it's going to be like what we did previously, kind of, with an extra twist. And then we keep on adding the period until we exceed 2 pi. Okay, so here we go. So what we're going to do is, instead of trying to solve this equation with a 2x here, let's make it like a problem that we looked at previously. So we're going to do a substitution, and we're going to let theta equal to 2x. So that gives us this. So then essentially we're solving the equation sine of theta is equal to negative 0.3. Well, we looked at this previously, and we found out that theta is equal to 3.447 or 5.978, right? But we're not done, because we're trying to solve for x, not theta. And we made the substitution, so what we need to do right here is we're going to take this 2x and substitute it back in for theta. And we'll have two equations to solve. So we know that theta is equal to this or this. So that means that 2x is equal to 3.447, or 2x is equal to 5.978. Okay, and I need to solve for x. So if I divide both sides by 2 here, then I get that x is 1.7235, right? And that corresponds to this solution right here. But I need to find the second one that is pi away from that, right? So then I have to do 1.7235 plus pi, and that gives me 4.865. Okay. And what I can do to check is I can add another pi to that, right? But that would send me to over 7, which is more than 2 pi, because 2 pi is 6.28. So from this one angle here, I get two solutions, and now I have to do the same for my other equation here. This gives me x is equal to 2.989. That's this solution, oops, this one right here. But to that, I need to add pi, so that's 2.989 plus pi, and that gives me 6.131. Oops, 6.131. And that's the solution over here. And I know that if I add another pi to that, I'm going to get a number that exceeds 2 pi. So here are my four solutions. X is equal to, and you should put them in order, 1.7235, or 2.989, or 4.865, or 6.131. So before you move on to the next video, what I want you to do is to master this idea of finding a period. And notice that if you change your period, especially if you shorten the period, you get more answers. And then I want you to master the substitution, because not only are we going to change the period in the next problem, but we're also going to include a horizontal shift as well. Okay? And you're going to be doing a lot with this step here. So make sure that you understand the substitution before you move on to the next one.